Okay, I lied. There's not just one more thing I want to show you. There's a few more things I want to show you. So the first is pretty quick, but it's that, okay, we've given a way to initialize or instantiate objects on the stack. So this object is a local variable of the main method here. And so when the main method dies, that object goes away. And also, we might not even know if we need an object or not. So just like before, with primitive types, we can dynamically allocate an object. And so for this, we also use the new keyword. So if I were to say here, instead of doing this static, we call it static initialization here, I would say, okay, I'm going to get a pointer to some dynamic memory that I'm pulling off of the heap. So now I understand Nick is actually a pointer to an object of type person. I would say that is equal to new person Nick 80 10,000. And so in this case, the way that I call the constructor is a little bit different. Rather than putting the parameters to the constructor directly after the variable name, what I do instead is declare a pointer, and then this pulls memory off the heap, and it calls the constructor as it does so, actually by specifying the name of the class. So we're actually kind of using the name of the constructor now to create this dynamic object. And so now I understand Nick is a pointer, so I have to make sure that anything I do to Nick has to go through the arrow notation now. So I'll say Nick age equals 100. And then to access the instance method, I use the arrow notation. So let's just check and make sure this does the same thing. It sure does. But there's a problem, of course. If I run valgrind, I see that there is a memory leak. I've lost 24 bytes in one block, which actually seems to indicate that these objects are 24 bytes large. But anyway, so if I got to make sure, again, every time there's a new, there should be a delete when I'm finished. Okay, when I'm finished using the object, I don't want to delete Nick before I print information about him. But once I'm like, okay, that's it. Now I can delete him. And let's compile this again. Run valgrind, and now we see we're good. Okay. So again, dynamic allocation. It's another way to call a constructor, but we understand that it actually takes memory off the heap. And so, we can actually create objects that don't belong to one particular method, and then we can instantiate them at runtime. So we don't even necessarily need to do this unless something happens at runtime. All right, so we have all that flexibility. But I'm going to give you a quick exercise on this, a very common use case of dynamic allocation when you want to clone an object, when you want to make a copy of an object. So I'll have you do an exercise on that real quick.